get removed with carbonyl and the oxygen is going to make a bond. C3 as it is, this carbon two as it is, bonded to OH. Okay. For example, one more example, please see. Don't write now, please see and try to understand what is happening. This will be always CH3 double bond O Cl plus, let's suppose you have CH3 CH2 OH. So what will happen? From here the hydrogen will leave and from here the chlorine. And oxygen will get attached to the. This will be as it is. CH3 C double bond O. Then you will have oxygen CH2 CH. Okay. So sometimes you can see like this. CH3 C double bond O Cl plus 1, 2, 3 carbon atoms and OH. This will give you 1, 2 carbon atom and then 3 carbons. 1, 2, 3. 1, 2, 3. Okay. Now all of these reactions are going to be in the presence of period. I will write that this as PYR. Okay. Please. By the way, one more thing is always present, that is HCl. I hope you can see that. यहाँ पे भी आपको HCl मिलेगा और यहाँ पे भी आपको HCl मिलेगा. Okay, so these are the reaction with acid chloride and specifically speaking, acetyl chloride. Okay, I hope you guys are done. If anyone is still writing, please let me know. Let me know if you are still writing. That will be with acetyl anhydride, है ना? या फिर acetic anhydride भी उसको बोलते हैं. क्या होगा? CH3 double bond O C double bond. ठीक है? Particularly made by 2 acidic acid. एसिड में से आप निकाल देंगे ना, देखिए आप कैसे रखा जाता है. Suppose we have an acid 3 bond O and OH. And we take H, O, C, and CSC. Same thing. Both of these are not acid. If I will remove water, 2 hydrogens and 1 oxygen, acetic anhydride. CSC C double bond O, oxygen double bond O. Okay, so this is the acetic anhydride we are going to react with. Acetic. The name of anhydrides are always carboxylic acid, which they are. Here, let's suppose CH3, CH3, O and H. यहाँ पे क्या होगा? Carbon get attached to the oxygen और ये oxygen पर क्या आ जाएगा? Hydrogen. होगा, ठीक है. This oxygen will have lone pair electrons and this carbon will have positive. It will be having lone pair, hydrogen will be delta positive. It will get CH3, C double bond O, which is connected to OCH3. It's not here right now. Now. It has, tell me, how is it now?
Yes,
Is it
yes,
any better now?
yes.
I think very small portion you left, na? देखिए. CH3 C double bond will get connected with oxygen, and this oxygen will get connected to hydrogen. ठीक है? OH हो जाएगा यहाँ. इसको copy कीजिएगा. Make sure it works tomorrow. Okay, Zaina, just give me a second. So there is I want to write. Zaina, let me know once you're done. Don't write in chat. ठीक है, Zaina? Turn your mic on and tell when you're chat. Sometimes I don't get notification for chat, है ना? मिस हो जाता है. Here also you why we are having no Zaina, है ना? Zaina, अगर माइक ऑन नहीं कर पा रहे तो बता दीजिए कि अंदर माइक ऑन today. Write some remarks. Is a as Just give me a second, guys. Yeah, ये बार-बार ऐसा problem. Right now, I have good connection, by the way. Like, not like bad connection.
Yes, sir, we can
Speed
hear
do I
you
have right
clearly right now.
right? या फिर से ये बोल रहा है my hello, am I audible? Hello.
Yes, sir.
By the way, you can see my screen.
Yes, sir.
C double. This group is known as capital. I'll that is why it is RC time emission. Second point is that why is pyridine used? Right with me, pyridine is used the acid, neutralize the acid. And it leads to equilibrium. And right, you will get some carboxylic acid. Right? If you see the reaction, you will see that you are going to get carboxylic acid. Now, if I am going to neutralize the HCl, that means productivity. What I'm doing, I am decreasing the concentration of product in both the cases because I have pyridine. Pyridine is basic, base will react with acid. So when the concentration of product becomes lower, the reaction shifts on the product direction. Makes sense, yes or no? Please tell me. The use of pyridine makes sense now. Amina, Rishita, Harsha, and Zaina, yes or no? Please tell me
Sir, can you repeat your voice was breaking?
again.
Explain again.
When
Your voice is.
we, my voice is breaking.
Yes, sir.
When we react alcohol with carbonic acid, uh, product, other product is steel, one of the byproduct. Similarly, when you react all it will get neutralized. So we can say that HCl and carboxylic acid in their respective reaction, when the concentration of products is each happens, the it shifts in the right direction. Do you guys remember something? First of all, am I audible?
No, sir.
Yeah, yeah, yeah. Just is How is it now? Well,
No, sir.
just be here, I will be join. Hello. Am I audible, guys? It's the same thing. Is it any better?
Yes,
Yes,
sir.
sir.
Yes.
Let's see if I share the screen. How it is. Am I still audible? Let me read one sentence. This reaction is also known as acetylation, as the reaction introduces acetyl group in alcohol. Was that clear?
Yes.
Do I need to
Yes, sir.
explain the pyridine? Do I need to explain the pyridine part once again?
Yes, sir.
Sure. So the basic principle is regarding the Lee-Chatterjee principle from chemistry. So we get HCl as byproduct and carboxylic acid as byproduct. Is that clear? First of all, when I react alcohol with carboxylic acid, I will get HCl as byproduct. When I will react alcohol with anhydride, I will get carboxylic acid as byproduct. Are these two things clear? Yes or no? Tell me.
Yes.
Yes, sir.
Yes. Okay, we are getting acid as the byproduct. Now, what I will do, I will add a base. Pyridine is a base. Now, when I will add base, what will happen? Acid and base, they will neutralize. They will neutralize. अच्छा, उसके बाद क्या होगा? The concentration of product is decreasing. When the concentration of product decreases, according to Lee-Chatterjee principle, what will happen? The system will shift in a direction where the product concentration increases. Because whatever change we introduce, the system will change the opposite. So what the system will try to do? System will try to increase the amount of product, and that will happen. If I increase the amount of product, that means the reaction is moving in the rightward direction. Does that make sense now? Yes or no, please tell me.
Yes.
Okay.
Yes, sir.
By the way, is everyone done noting down? Guys, anyone still writing?
No, sir.
One is writing. Okay. Right. Next point. Also show similar reaction. Okay. Reaction is the precision of casting. Important. And
Sir,
type of
it will be
important, type of important. Yeah.
RCOCl.
RCOCN.
Yes, sir. The first reaction.
The answer. Correct. So preparation of now the starting material for aspirin, it is beta hydroxy carbonic acid. We have carbonic acid and in position we are going to have OH. Okay. We are going to have OH. This is a common salicylic acid. Salicylic acid. I will be understood it's C double bond O, C double bond O, and this is acetic anhydride. Then we are going to get what the H will be removed and alkyl group will be added. So we are going to make everything as it is except the hydrogen because that OH bond is going to break. Now COOH. When the OH bond will break, you will have oxygen atom here. Then you will have C bond O and CH3. This is the acetyl group. This is what? This is acetyl acid, whose common name is aspirin. Aspirin जो दवा है, ठीक है, this is the preparation of aspirin. Now this particular ये पूरा जो process है, it is done in acidic condition so that we can retain the carboxylic acid next. Because if you are going to add pyridine in this particular case, this carboxylic acid also react. But carboxylic acid and the aspirin, that is very keep things in acidic medium, because even if I have some like water molecule, only water also, in water you will have some purities in the form of Mg2 plus and Ca2 plus. So that can also displace the hydrogen, and वो यहाँ पे Mg2 plus आ सकता है यहाँ पे Ca2 plus. So that's why we keep acidic. ठीक है? Please write this down. Let me know once you're done.
Can you scroll up 1 second?
Sir, why are we getting only half the number of carbons in the product?
Sorry, what are you getting?
We're not getting all the carbons in the product.
No, I mean that will be इतना मिला है ना आपको, right?
Yes.
Plus you will C double bond O and OH. ये जो हाइड्रोजन है हाइड्रोक्सी ग्रुप का हाइड्रोजन है, यहाँ पे क्या है? We are concerned the preparation aspirin. That is why you only tend to write aspirin. ठीक है? जैसे method of preparation of haloalkane में generally we used to focus on. Then anyone still writing? Right. Now these are the reactions that we have to see in case of cleavage of OH bond. Okay. अब जो दूसरा पार्ट है पास B part is write with me. Reaction involving cleavage of carbon and the hydroxy group bond. That is COH bond. Okay. So in the previous case, we have seen that if the OH bond is very polar, if the OH bond breaks easily, same concept हम यहाँ पे भी लगा सकते हैं. Higher the polarity of COH bond, easier it is to break the bond. Easier it is to break the bond. When the carbon oxygen will carbon oxygen bond will break. This oxygen is going to take it out because that's electrolytic. Heterolytic leaving will happen. Heterolytic will happen. Carbon will get a positive. When the carbon will get positive charge, that positive charge will be move from alkyl group with the plus I. So we can write as the number of alkyl group increases at alpha carbon. The electron density. This is the electron density. Around 10 atoms increases, making the bond more polar and carbocation form and the carbocation form more stable. ठीक है, तो देख लीजिए यहाँ पे ध्यान से वो क्या रहा है. I have carbon and I have one R group attached and then OH. ठीक है. So this particular group, this group, it is giving some electron density to oxygen atom, which is making delta negative. If I have two R groups attached on the carbon and then I have OH, then this group will be giving more electron density, making this more delta negative. Then we can have these are this carbon atom which is attached to the OH. All of these three will be giving much higher electron density. जितना ज्यादा ऑक्सीजन पे डेल्टा नेगेटिव होगा, here polar bond this will become. Negative, that means oxygen break the bond and leave, right? And similarly, once it leaves, the 3 degree bond will be, that is by reactivity. Reactivity. इसमें क्या करना है? 3 degree is fastest, followed by 2 degree, followed by 3, and then CH3. This is the slowest. Okay, if you're done, then you will write the first reaction. The reaction with hydrogen. Reaction with hydrogen halide. लिखिए and raise your hand once you're done. एसिडिक कैरेक्टर कराया था आप लोग को टेस्ट. नेक्स्ट स्टेप हो जाएगा. तो आई थिंक एवरीवन इज डन ना. अब यहाँ पे ना ध्यान से देख लीजिएगा, उसके बाद लिखिएगा. ठीक है, अभी मत लिखिएगा. reaction with hydrogen halide. We have seen this reaction in the previous chapter. Na? Alcohols react with HX hydrogen halide and form RX. ठीक है, जो जनरल रिएक्शन क्या है, ROH plus HX will give you RX plus H2O, right? So if I talk about the reactivity of HX hydrogen halide, then in this case that hydrogen halide which can easily break, that will be the fastest to react. So HI bond is the largest. This will be fastest to react, followed by HBr, followed by HCl. Okay. And the HF, it does not even react. It is so slow that it does not react. Okay. The bond between HF is very strong. So only these react. So if I talk about the reactivity of alcohol, then for this we have already seen whenever the OH bond is going to break, the reactivity will follow our order, which is 3 degree will be fastest, followed by 2 degree, followed by 1 degree, and then you will have CH3. Okay. This is general reactivity. Achha. Now, since HCl is very slow to react, HCl is very slow because you can see the reactivity of HX. HCl is very slow to react, and the alcohols for 2 degree, 1 degree, and CH3OH, it needs some catalyst also. ठीक है, उसके लिए remarks में हम लोग लिखेंगे. Please write this down. Raise your hand once you're done. Raise this point down. Very general points. I hope you can see the Lucas reagent coming very soon. HCl and ZnCl2. Same thing is coming once again. Just waiting for Rishita now. ठीक है, ध्यान. Please write remarks. आपने सबसे पहला पॉइंट लिखा, due to over reactivity, due to lower of HCl with 1 degree and 2 degree alcohol, we use anhydrous ZCl2 as catalyst. Okay. Second point is the Lucas reagent HCl plus anhydrous ZnCl2 is also known as Lucas reagent. Also known as Lucas reagent. Third is Lucas reagent is used for distinction of just give me a second, please. Okay. So it is used for Lucas reagent. Lucas reagent is used for distinction of 1 degree, 2 degree and 3 degree alcohols. ठीक है, बेसिकली ध्यान दीजिएगा जरा, ये रिएक्शन होता कैसे इसको थोड़ा सा डिटेल में समझ लेते हैं, है ना। ये वाइवा में आपको पूछा जा सकता है कुछ सवाल, ध्यान से देखिए। वी हैव अल्कोहल प्लस लुकास रिएजेंट, ठीक है। लुकास रिएजेंट में you have HCl and ZnCl2, here we have alcohol. We have seen that alcohols are quite soluble in water. Even Lucas reagent it will be having HCl ZnCl2, both of these will be also soluble. ये दोनों क्या है, the reactant these are soluble in water. अच्छा, when both of these are going to react, they will form RCl. Lucas reagent में HCl है, so they will form RCl plus H2O, and there will be ZnCl2. तो बाकी H2O ZnCl2 everything will be what? It will be soluble. Only RCl will be what? Precipitated, or it will be having white PPT or turbidity बोल सकते हैं. It does not precipitate really, it gets dissolved like chalk. It doesn't settle down very easy. So I will write white turbidity. Basically मतलब है that it does not dissolve in water, ठीक है. And that is why we use Lucas reagent. कोई आपसे पूछे HBr क्यों नहीं यूज करते, आप बोलिएगा HBr से डिसॉल्व हो जाता है, ठीक है। HI क्यों नहीं यूज करते सर, HI थोड़ा सा ना डिसॉल्व, मतलब HI क्यों नहीं यूज करते, बिकॉज RI it can get dissolved, ठीक है। आप ये आंसर कीजिएगा, why we use HCl. So you will say sir we use HCl because it will give us alkyl chloride which are insoluble in water, और वो white turbidity दे देगा, ठीक है। अच्छा, also one more reason is that ये reaction थोड़ा slow करता है HCl. That is why when we have 1 degree alcohol and we are going to use Lucas reagent, so there will be no reaction at room temperature, no reaction at room temperature, but you will get, या फिर समझ लीजिए turbidity on heating, turbidity, you will get turbidity on heating. अच्छा, if I did not use HCl and I use HI, so HI is very reactive, so it will not even see whether it is 1 degree, 2 degree or 3 degree. It will even react fastly with 1 degree alcohol. That is why I am not going to use HI. Similarly, in the second case, that is 2 degree alcohol, if I am going to use Lucas reagent, then I will be getting turbidity after some time. After some time. After some time is approximately 5 to 10 minutes. Lekin just to be sure, practically speaking, we sometimes even have left it for 30 minutes. ठीक है, पता चलता है कि it is 2 degree alcohol only, but due to some conditions, like the temperature that time or the humidity, like because of many certain conditions, what happens? You have to even sometimes leave for 20-30 minutes. ठीक है, अच्छा, even if it does not give after 20-30 minutes, then we heat it. ठीक है ना। चलिए, तीसरा है आपके पास क्या, 3 degree alcohol. And when you react this with Lucas reagent, it will give you turbidity immediately. ठीक, so you have got a sample. They said that it is alcohol. You have to find out whether it is 1 degree, 2 degree, or 3 degree. तो आप क्या कीजिएगा वहां पे, you will add Lucas reagent. If you get turbidity immediately, it is 3 degree. Then if it does not give, you will wait for 5, 10, 20, 30 minutes. If it does not, if it gives turbidity, it is 2 degree alcohol. If it still does not give turbidity, then you will heat it, and then it will give you turbidity, and that is 1 degree alcohol. ठीक है, तो आपके पास सवाल मान लीजिए इस तरह से आएगा, देखिए। आई एम गिविंग यू अ क्वेश्चन, दिस इज अ सैंपल क्वेश्चन फॉर द डिस्टिंक्शन, ठीक है। क्वेश्चन क्या है, हाउ विल यू, oh, how will you, how will you distinguish between propane 1 or and propane 2 or, ठीक है, ध्यान दीजिएगा। अच्छा, बाय द वे, डिड यू राइट वन टू, ये सारा लिख लिया आप लोगों ने? यस और नो, प्लीज टेल मी क्विकली. आमिना, रिश्ता, हर्षा एंड जायना, डिड यू राइट
Yes,
this
sir.
part? Anyone still writing? Anyone still writing? ठीक है, how will you distinguish between propane 1 और,
Sir,
ठीक है जायना, हाँ ठीक है, और
1 second, sir.
1 second.
Sir, your screen froze for me, so it wasn't loading.
What Zaina?
Your screen had frozen up for me, so I just had to write the reaction.
हाँ लिख 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 नो प्रॉब्लम. अच्छा ऊपर और जाना है, बताइए ना कहाँ लिखना है.
ये सर थोड़ा ऊपर.
और थोड़ा ऊपर. अच्छा if it is too much to write then आप स्क्रीनशॉट और ऊपर. बहुत ऊपर.
No, that's all. That's all.
That's all.
Yeah.
If it is too much to write, take a screenshot. आप फिर बाद में कंप्लीट कर लीजिएगा यार.
Done, sir.
Done. Now, see how will you distinguish between propane one and propane two? तो देखिए जो बच्चे होते हैं ना सिर्फ थ्योरी पढ़ के चले जाते हैं. They don't do any question. They don't practice any question. वो जानते हैं आंसर क्या लिख के आएंगे. We will use Lucas reagent. They will be very happy. एक मार्क्स मिल जाएगा हमको, है ना. क्या लिख के आएंगे. We will use Lucas reagent बस. Is the answer correct? Yes or no? Please tell me. आंसर सही है हाँ या ना.
Yes.
बताइए अगर हमने आंसर लिखा तो सही है लेकिन मार्क्स नहीं मिले. ठीक है. सो अब यहाँ पे देन दैट स्टूडेंट विल से दैट सर तो मतलब बोर्ड्स में होता है ऐसे तो ठीक है. देन दे विल बी लाइक ओ माय गॉड आई डिड नॉट गेट द मार्क्स दैट आई वाज एक्सपेक्टिंग. बट अगर कोई टीचर सेम चीज कर दे देन यू विल दे विल बी लाइक सर तो चाहते हैं जो लिखाया है वही आंसर लिखे हम. थोड़ा सा भी क्रिएटिव होने का मौका नहीं देते, है ना. सर बोलते हैं कि जो लिखा है जो लिखवाए हैं वही बिल्कुल लिखना है. तो दैट्स यहाँ पे वो काम करता है. ठीक है ना. आपको आई विल गिव यू अ फॉर्मेट. ठीक है. देयर कैन बी मेनी क्वेश्चंस ऑन दिस डिस्टिंक्शन. देयर इज अ फॉर्मेट दैट आई हैव सीन इन द मार्किंग स्कीम्स ऑफ बोर्ड केमिस्ट्री पेपर. ठीक है. एंड इट्स द सेम चाहे आपको डिस्टिंक्शन हो 1 डिग्री 2 डिग्री अल्कोहल में. और इफ देयर इज अ डिस्टिंक्शन बिटवीन phenol and alcohol, if they ask for distinction between phenol and carboxylic acid, or if they ask for distinction between aldehyde and ketone, aldehyde and carboxylic acid, different types of aldehyde, all of these things, there is a certain pattern that CBSE follows and what CBSE wants you to write. ठीक है. तो आप क्या लिखिएगा यहाँ पे ध्यान. फर्स्ट ऑफ ऑल आपको आना चाहिए कि अगर हम प्रोपेन वन ऑल लेंगे दैट मींस 1 2 3 कार्बन एटम्स एंड OH and I will react this with glucose. This is not what you have to write. This is something that will be in your head. You can write it down, but that will not give you marks. Then it is going to give you white turbidity on heating. But if I use propane 2-ol in the presence of glucose reagent, it will give me white turbidity after 5 to 10 minutes. ठीक है. इसी को आपको वर्ड्स में कैसे लिखना वो हम आपको you will write propane 1-ol gives white turbidity with when treated with glucose reagent, but propane 2-ol gives white turbidity with glucose reagent after 5 to 10. ठीक है. अगर आपने ऐसे लिख दिया आपको पूरे मार्क्स दोनों ही बता देना. आपको आपने सब कुछ बता दिया है ना कि व्हाट इज द रिएजेंट दैट यू आर गोइंग टू यूज. ठीक है. और प्रोपेन 1-ol कैसा बिहेव करेगा, प्रोपेन 2-ol कैसा बिहेव करेगा. दिस इज द फॉर्मेट दैट यू हैव टू ऑलवेज फॉलो. Whenever they say how will you distinguish between X and Y, you will say that when X reacts with certain reagent, it gives this color, this particular. When Y reacts with this reagent, it gives that. ठीक है. Once the organic chemistry syllabus is completed, I will give you the complete chart type of thing. There you will have all the test. उसमें certain examples. ठीक है. जल्दी कॉपी कीजिए जरा इसको. Let me know once you're done. Rishita, you will be attending the JE class, no? Rishita?
Yes, sir.
So I will leave you guys on 10 more minutes. ठीक है? आज का टॉपिक ऑलमोस्ट हो ही गया है. Just waiting for Amna. टॉपिक आप लोग कवर कर देते हैं. ऐसे भी करेक्ट करो. Amna, are you done? Amna, are you done?
Yes, sir.
Moving on. Right? Mechanic. ठीक है. मैकेनिज्म में चीज ध्यान रखिएगा. जो आपके पास 1 डिग्री अल्कोहल होता है ना, 1 डिग्री अल्कोहल reacts with HX via SN2. न्यूक्लियोफिलिक सब्स्टिट्यूशन बाय मॉलिक्यूलर. ठीक है, तो सिंगल स्टेप में ही हो जाएगा. अच्छा, व्हाट अबाउट द अदर टाइप ऑफ अल्कोहल? ठीक है, अदर टाइप ऑफ अल्कोहल दैट मींस 2 डिग्री हो गया या फिर बाकी सारी चीजें, दे विल रिएक्ट लाइक दिस. फर्स्ट स्टेप इज HX. This will dissociate into H positive and X negative. सही. सेकेंड स्टेप क्या है? सेकेंड है आपके पास when you have something like this R. अच्छा, बाय द वे राइट नाउ आई एम शोइंग यू 1 डिग्री अल्कोहल ओनली. ठीक है, लेकिन ये जनरल है सबके लिए. ठीक है, फॉर 2 डिग्री क्या करेगा, पहले H प्लस के साथ क्या करेगा, एंड दिस विल गिव यू ऑक्सीजन विथ 1 हाइड्रोजन एंड 1 मोर. ठीक है, नाउ द ऑक्सीजन गॉट अ पॉजिटिव चार्ज. ठीक है, अब ये पॉजिटिव चार्ज ऐसे इसको मिल गया, देन व्हाट विल हैपन, वो यहाँ से निकलना चाहेगा. ठीक है, चलिए उसको एक काम करते हैं, अभी नहीं निकालते. ठीक है, आई विल कीप दिस फॉर 1 डिग्री. 1 डिग्री को ज्यादा तक एसएन टू कैसे होगा, so then what will happen, the X negative will come. अच्छा, by the way, why the alcohol is, why the water molecule is not leaving, because it will create a carbocation. That carbocation will not be stable. तो वापस से फिर alcohol यहाँ पे attach हो जाएगा. ठीक है, so what will happen, X negative will come and then there will be a reaction like this. Oxygen with 2 hydrogens and a positive charge. Now this carbon atom will be having a highly delta positive charge because it is connected with oxygen with a positive charge. Oxygen क्या कर रहा होगा, इलेक्ट्रॉन बहुत ज्यादा खींच रहा होगा, and then the X negative will come, it will attack here and this will give you. अच्छा, ये जैसे यहाँ पे अटैक करेगा, दिस वाटर मॉलिक्यूल विल देन लीव एंड यू विल गेट RX plus H2. ठीक है, दिस इज व्हाट इज गोइंग टू हैपन विद 1 डिग्री. अच्छा, 2 डिग्री रिएक्ट्स, 2 डिग्री अल्कोहल्स react with HX via SN1. Therefore, they can give rearranged product. ठीक है, क्या है rearranged product, वो हम लोग एग्जांपल्स देखेंगे. दोस्तों, अपने haloalkane halorine with me तो ज्यादा अच्छे से समझ में आएगा, because we have discussed that the same thing in haloalkane halorine. थोड़ा अच्छे से डिटेल में हम लोगों ने करा. ठीक है, दोस्तों, नॉट इन हलाल की हैलोरिन का तो होगा, डोंट हैव टू वरी. अभी इसको नोट्स में कम से कम लिख दीजिए. इन डिटेल यू विल सी इन व्हेन यू आर गोइंग टू डू हलाल की. अच्छा, बाय द वे, आमना, 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 ये ऑडिबल?
Yes, sir.
आपने ये लेक्चर कंप्लीट किए हलाल के हैलोरिन के, जो आप देखना चालू किया था आपने रिकॉर्डिंग्स?
Sir, yes, sir.
हो गया सारा, नोट्स वोट्स सब कंप्लीट है?
हाँ जी, नोट्स भी होंगे.
चलिए, अच्छा कोई डाउट नहीं आया लेक्चर ऐसे रिकॉर्डिंग से तुमको समझ में आ गया सब कुछ?
हाँ जी सर, एक दो थे बट फिर मैंने वही रिकॉर्डिंग्स को 3-4 बार फिर से देखा तो फिर इट वाज फाइन।
ठीक है, वेरी गुड। चलिए, सो एनीवन स्टिल राइटिंग? एनीवन स्टिल राइटिंग? No one is writing? ठीक है, ठीक है. So there is a reaction like this. We have 4 carbon atoms, 1, 2, 3, 4, and यहाँ पे आपके पास OH है, and here you have a CH3 group. ठीक है. Now when this reacts with HBr, what we expect? We expect to get a product like this. We are here and the CH3 as it is. ठीक है. But we don't get this product. The product that we get is something like this. Carbon atoms. Just give me a second. There is a CH3 group here. Just give me a second. So we have all the 4 carbon atoms. The CH3 group is here, okay? And the Br groups attaches here. Now we need to understand what is the mechanism. Okay? So abhi aap log na please, those who have already done this OP and those who are first time seeing this type of thing, that is especially Zaina and Amina maybe also. Okay? Please leave your pen aside and try to understand what is. ठीक है, ध्यान से सुनिएगा, समझ में आ जाएगा, बहुत आसान, ज्यादा हार्ड. You have 1, 2, 3, 4 carbon atoms. I have a CH3 group here, and I have the OH group here. ठीक है. अब यहाँ पे ऐसे करके आपके पास H plus आया. ठीक है. This is lone pair. This is lone pair. This is going to attack on the H plus. What will happen? 1, 2, 3, 4 carbon atoms. There will be CH3. यहाँ पे आपके पास क्या आ जाएगा? Oxygen. The 2 hydrogens, same as we have seen previously. But since it is a 2-degree alcohol, you can see that this is 2-degree alcohol. What will happen? The oxygen with 2 hydrogen, it will leave as water and make a carbon. Basically, you will get, actually, all of these are what? Reversible type of reaction. Na? H plus यहाँ पे जुड़ भी सकता है, फिर निकल भी जा सकता है. ठीक है, but it is going to be in the more on the forward direction. तो आपको क्या मिलेगा? You will get 1, 2, 3, 4 carbon atoms, and there will be CH3, and there will be a positive charge. ठीक है. अच्छा, if I look at this carbon atom is having 3 bonds and means there will be 1 hydrogen also. अच्छा, Zaina, can you please turn your mic on? Zaina, can you please turn your mic on? आप सुन रहे हैं ध्यान से Zaina? Here we will be having electrons, correct? In this carbon hydrogen bond, there will be electrons, correct? Yes or no? Electrons means negative charge, and just adjacent to it we have positive charge. So for a second, can I say that these electrons can move here with the hydrogen for a millisecond maybe? It can happen because of the positive and negative attraction. Tell me, Zaina, is it possible? Yes, for a millisecond. So here, electron has negative charge, and just adjacent to it, it has positive charge. And this hydrogen atom, which is also very small. Because the positive charge can pull the electron density, and with that electron density, the hydrogen can easily move from here and here. उसके लिए तो बहुत ज़्यादा चेंज नहीं, क्या ख्याल है? सही. For a millisecond maybe. Yes or no, Zaina? Tell me. है ना? It can happen for a millisecond. हम लोग इस पे agree कर सकते हैं. For a millisecond it can happen. है ना? थोड़ा सा कहीं आपने shake कर दिया, थोड़ा सा heat आ गया. For a millisecond it can happen, and I will get something like this: CH3, Since the electron is moving to the positive charge, this will become neutral, and here we will get hydrogen. And the carbon atom from where the hydrogen has shifted, that will get a positive charge. क्या ख्याल है?
Yes, sir.
सही है. Now, what will happen? Once this happen, even for a millisecond, this is 2 degree alcohol. This is 3 degree, sorry, this is 2 degree carbocation. This is 3 degree carbocation. 3 degree carbocation will be much more stable than the 2 degree carbocation. And that is why what's going to happen? Once for a millisecond, it happened like this. The hydrogen shifted. It will not come back. Or if it, even if it comes back, it will be very slow. Or it will be very low concentration. This is known as hydride shift. हाइड्राइड शिफ्ट. देखिए एक सेकंड हो तो क्या, लेकिन लेट सपोज आई हैव 10 to the power 5 molecules. 10 to the power 5 molecules में मान लेते हैं 1000 molecules got this type of rearrangement. 1000 ज्यादा हो जाएगा, मान लेते हैं 100. ठीक है, 100 molecules became 3D. They will never come back. अच्छा, अब जो remaining है, from remaining again 100, 90, 50 can go to 3 degree. They will also never come back. So slowly and slowly what will happen? This hydride shift will take place. ठीक है, और ऐसा हो जाएगा धीरे धीरे कि all the carbocations will be hydride shifted and it will become from 2 degree to 3 degree. Make sense है ना ये सुनो?
Yes, sir.
आपको बस इतना समझना है कि 2 डिग्री से ये हाइड्राइड शिफ्ट मिली सेकेंड के लिए हो सकता है. इट इज पॉसिबल. वंस यू गिव द गेट द आइडिया ऑफ पॉसिबिलिटी, देन यू विल कंप्लीटली अंडरस्टैंड 3 डिग्री से वापस 2 डिग्री तो कभी नहीं जाएगा. ठीक है, एंड नाउ व्हाट विल हैपन, द ब्रोमाइड आयन दैट वाज roaming around here and there, that bromide ion, it will now attack on the carbocation like this, and I will get 1 2 3 4. The CH3 is here and the bromine is here. Does this make sense? Yes or no? Please tell me, Zaina.
Yes, sir.
Please copy कर लीजिए इसको जरा. अच्छा. By the way, there are two reactions that you need to do from the NCERT because this is from the method of preparation of haloalkane. या तो आप नोट से कर लीजिए NCERT से. नहीं, नोट से करना पड़ेगा. NCERT में आपको ऐसे ही दिया है. Reaction with phosphorus halides. Third is reaction with ionyl chloride. ठीक है, both of these are already covered in method of preparation of haloalkene. ठीक है, तो आपको बहुत ज्यादा इसमें परेशानी नहीं करनी पड़ेगी. Also these are not they don't have any depth in it. reactant product टाइप का है. एक बार फिर से देख लीजिए या फिर कॉपी लिख लीजिए, वो हो जाएगा. Write this down.